everybody. It's the Good Math Guys, Mike and Sean, back at you again with our second video on digit roots. I've kind of prepared a sheet for you here because our first program, the last one we did on digit roots, was revolved around repeated addition to get us to a single digit response. So I recorded this so that we can see what we did there. Adding all of this up right here, the way we did in program one, gets us to a 44. 44 was not a single digit response, so we added the two fours to get the 8, which was the digit root for this particular number. In today's video, what we're going to do is explore something called casting out 9's. Now, to cast out means to throw away. So if you guys got a stinky old smelly pair of sneakers at home and you cast them out, what you're doing is you're throwing them away. Same thing we're going to do with 9's that we see here. Now, there's two kinds of 9's. There's the easy to see 9's, and there's the hard to see 9's. This would be an easy to see 9 right here, so we're going to throw it out, cast it out by drawing a line through it, so it's gone. I don't see any more of those easy to see 9's, but I do see 9's if, for example, I add 6 and 3. 6 and 3 is equal to 9, therefore we're going to cast out the 6 and we're going to cast out the 3. So we've effectively cast away another 9. Looking for more of those, I see a 4 and I see a 5. 4 and 5 makes 9, so we'll cast the 4 and the 5 away. And by this time, kids are jumping out of their seats because they see another one, the 2 and the 7, leaving an 8, where I cannot cast out another 9, meaning that 8 is our digit root. So in both methods, we got the digit root of 8. The repeated addition got us to 44, 44 got us to 8, and casting out all the 9's we saw gets us to an 8. Let's go down to this string of numbers and give it a try. I don't see any easy to see ones like we saw right here, but I do see some 9's. How about the 2 and the 7? 2 and 7 makes 9, so we'll cast the 2 and the 7 out. How about the 3 and the 6? That makes 9, so we'll cast that away. So what we've got right now is a 4 and an 8. So if you want to, what we can do is go back to this method up here, repeated addition. We can say 4 plus 8, because that's what's left over here. 4 plus 8 is 12. That's not a single digit, so we're going to continue the adding process. 1 and 2 is 3. So we arrive at a digit root of 3. Now, guess what? Let's go back to this 4 and 8. 4 and 8 making 12. Is there a 9 and 12? Yeah, there sure is, and we can get to it by maybe giving one of these 4 to this 8. 1 and 8 would make 9, which leaves a 3 here. I'm just going to put it over there for now to make sure we know it's there. And don't you know that that particular 3 is the only digit that we have left in this string then, making 3 the digit root. So there's a number of different ways that you can manipulate these numbers to be able to find 9's and cast them out. And it's a much more efficient method, much quicker than having to do this repeated addition that we did up here. Let's try one more model, and then we're going to give you guys a chance to practice before we do the next video, where Sean is going to show you how to use digit sums, either way you get them, repeated addition or casting out 9's. He's going to show you how to use digit roots to check any multiplication problem, so you no longer will need to do long division to check multiplication. So let's do this last model, and then we'll say goodbye for the day. Don't see any readily available, but I do see a 1, a 2, and a 6. And 1 plus 2 is 3, plus 6 is 9, so we cast those 3 away. I do see a 1 and an 8 make 9, so we'll cast those out. Leaves a 4, so guess what? Our digit root there is 4. Hopefully you'll like this a lot. Hopefully you'll like it a little bit more than this method up here where we did the repeated addition. That all being said, for now, this is the Good Math Guys saying we really look forward to the next program on checking multiplication problems. So for now, we'll say bye-bye.